Let's take a look at copper. Copper is a soft, bright, shining, malleable and ductile metal of reddish color with very high thermal and electrical conductivity. It's not weldable, except on red heat. Its tensile strength is high. Copper is extracted from ores, such as malachite. After calcining the ore, it's mixed with silica and coke. Then it is oxidized in Bessemer converter, where removal of major portion of iron and sulfur compounds is executed. The crude copper is thus produced is known as blister copper, which is cast into small pigs. Copper does not react with water, but it slowly reacts with atmospheric oxygen to form a layer of copper oxide, which protects the underlying metal from corrosion. A green layer of verdigris copper carbonate can often be seen on all products. This layer is called patina. The alloying elements most frequently used with copper are zinc, tin, and lead. Some of the important alloy made with copper is brass and bronze. Brass is an alloy of 60–90% copper and 10 to 40% zinc. The color is silvery white for low content of copper and copper red for higher content. Brass may be either cast or wrought. Brass for casting usually contains 30 to 40 zinc. Tin 2% to 3% when added increases hardness but decreases ductility and strength. Aluminum 1 to 6% when added raises the strength but decreases the ductility. Cast brass is stronger and more ductile than either of its components, copper and zinc. Bronze is an alloy of copper and tin, with one or more additional metal. When copper 95% is alloyed with tin 5%, the bronze is known as coinage bronze, used for making coins. Copper 88% and tin 10% and zinc 2% results in gunmetal, used for making valves and bearings. Bellmetal is produced by alloying copper to zinc and nickel. It's used for making utensils, fittings, and electric goods. Zinc is a bluish-white, lustrous metal, less dense than iron and hard and brittle at most temperatures but becomes malleable between 100 to 150 centigrade Celsius. Above 210 centigrade Celsius, the metal becomes brittle again and can be pulverized by beating. Lead is a soft, highly malleable, ductile and heavy metal with a density exceeding that of most common materials. Pure lead can be stretched with even fingernail. It has a blue-gray color and dull metallic luster when freshly fractured. When exposed to moist air, it loses its luster due to oxidation. The characteristic properties of lead also include its poor electrical conductivity and high resistance to corrosion. Tin is extracted from black oxide of tin, cassiterite, by crushing, roasting, and melting in a way similar to that of copper. It's silvery white, lustrous, and extremely malleable metal, so soft that it can be cut by a knife, but harder, more ductile, and strong than lead. It's highly resistant to corrosion and has a low tensile strength. Chromium, it is steely gray, lustrous, hard, and brittle metal, which takes a high polish, resists tarnishing, has a high melting point and corrosion resistance. Titanium is a lustrous, silver-colored, quite ductile metal with low density and high strength. It's resistant to corrosion in seawater, aqua regia, and chlorine. In its unalloyed condition, titanium is as strong as some steels but less dense. Nickel is a brittle, silver-colored metal which takes good polish and at ordinary temperatures does not tarnish or corrode in air. It's almost as hard as soft steel for more malleable, and when rolled and annealed it's stronger and almost as ductile. Now we finished all the subjects for this week. Next week we are going to examine our last group of basic materials: wood, polymers, bitumen, paints, varnish, and linoleum.